Our next section is something that will really help those of you who are moving forward in college math classes and end up taking Math 141, college algebra, or I guess here it's called Pre-Calculus 1. In that course, you're going to do dividing a polynomial by a polynomial. We're going to introduce the idea of dividing just by taking a polynomial divided by a monomial. In other words, something with lots of terms divided by one term. Basically, the goal is going to be to take this problem, something like 6x plus 10 divided by 2. We're going to take a big problem and break it down into smaller problems, where you take each term of the top and divide it one at a time by the bottom term. So we took the big problem and converted it to two smaller problems. Here, 6x divided by 2 is 3x. 10 divided by 2 is 5. So 3x plus 5 would be our answer. Let's try that with one here that's got a few more variables in it. Here we've got 3x to the fifth plus 6x squared minus 8x divided by x. There's three terms on the top, so when we split it up, we're going to have three fractions. A fraction plus a fraction minus a fraction. Those plus and minus signs come from those signs in between the terms on the top. So we're going to have 3x to the fifth divided by x plus 6x squared divided by x minus 8x divided by x. Some people do this step in their head. I encourage you to write it down. It's always good to write down your steps so that you don't accidentally make little mistakes. Another thing that I do here that helps me visually is to remember that x is the same thing as x to the first. So when I'm doing something like 3x to the fifth divided by x to the first, I remember from my properties of exponents early on in chapter 5 that when you're dividing, you subtract the exponents. So here we do 5 minus 1, and we would get 3x to the fourth. Same thing on the next one. X squared divided by x to the first, 2 minus 1 is 1. We get x to the first, which is just x. For that last one, we have a minus at the front. And when you have exactly the same power of the variable on the top and bottom of the fraction, they cancel out. So here, for that last term, we just get minus 8. And that's it. So these problems aren't maybe as bad as they look at first. It's just about taking the big problem and breaking it down into multiple smaller problems. Let's try a few more. Here we have 9x to the fifth minus 12x squared plus 3x divided by 3x squared. So here we're going to have our first term, 9x to the fifth divided by 3x squared, minus our next term, 12x squared over 3x squared, plus our last term, 3x over 3x squared. So we took that big problem and broke it down into three smaller problems. So our first one, 9 divided by 3 is 3. X to the fifth divided by x squared. You subtract the exponents, 5 minus 2, and it becomes x cubed. On our next one, we've got the same variable power on the top and the bottom, so they just cancel each other out completely. And we have a minus in the front. 12 divided by 3 is 4. Now take a look at that last fraction. We've got a plus in the front. Here, there's a 3 on the top and the bottom. It works the same thing. If it's the exact same thing on the top and the bottom, they cancel out like that. Now notice what's different about this one. Here, we have x to the first on top, x squared on the bottom. You might remember something we talked about earlier on in chapter 5, that when your larger exponent is on the bottom part of the fraction, you're still going to subtract the exponents, but you put the result on the bottom. The result goes wherever the larger exponent was. So here we do 2 minus 1, and we would have x to the first on the bottom part of the fraction. And since there's nothing else left for the top part, we would put a 1 up there. So this would be our answer for that one, 3x cubed minus 4 plus 1 over x. So it's really important for this section. If you're finding some of these things confusing, it may help to go back and watch the videos for 5.1 to 5.4 to refresh your memory about those basic exponential properties. Let's try one more example. 30x to the 7th plus 10x to the 4th minus 5x squared, all that divided by 5x squared. So let's take this one problem and break it down into 3 smaller problems. We have the first term divided by the bottom part plus the second term divided by the bottom part. It's the same bottom part for all of these when we split them up. And because there's a minus in front of the next term, we'll have a minus in front of our next fraction. Our third term divided by the bottom part. So we took one big problem and break it down into 3 smaller problems. So for that first part, 30 divided by 5 is 6. X to the 7th divided by x squared, we subtract the exponents 7 minus 2. It becomes x to the 5th. Then 10 divided by 5 is 2. X to the 4th divided by x squared, we subtract the exponents 4 minus 2. We would have x squared. Then we have a minus. Now notice that last one, x squared and x squared cancel out, 5 and 5 cancel out. When you cancel out all the terms from the top and bottom of a fraction, it's like having a 1 left on top and a 1 left on the bottom. And 1 over 1 would be 1. That's something you have to be careful about. When you're canceling out part of a term in a fraction, if you cancel out everything from the top or bottom of a fraction, there would be a 1 still remaining there, not a 0. So here we get 1 over 1, and we got minus 1 for the last part of that answer.